Hey guys, today we will discuss integration of rational functions by a method called partial fractions. So let's say that I would like to integrate 5x minus 3 divided by x squared minus 2x minus 3. Right, so this is what I want to integrate. Well, one approach that we learned so far was by means of u substitution. So you can say maybe if I let u is equal to x squared minus 2x minus 3, then magically du will be something like 5x minus 3 times dx. However, the du here is 2x minus 2 dx, right? So if I make the substitution, I'll get something like 5x minus 3. In place of dx, I can do du divided by 2x minus 2. And here I get x squared minus 2x minus 3 is u. Okay, but how am I what am I going to do with 5x minus 3 divided by 2x minus 2, right? How do they cancel? So this substitution trick doesn't seem to work. So then one says that if we could somehow manage to break the rational function into simpler forms, maybe the integration will become easier. So what do I mean by this, right? So what do I mean by this? Well, what is x squared minus 2x minus 3? I can split minus 3 as minus 3 times 1, so product gives minus 3, the sum gives minus 2, so I have x minus 3 and x plus 1, right? Okay, fine. How does this going to help? Well, 5x minus 3 divided by x minus 3, x plus 1 can be written in the form 3 x minus 3 plus 2 x plus 1. You can check it. I mean, if you bring to the common denominator, which is x minus 3 times x plus 1, you will see that your denominator will become 5x minus 3. Well, then integration of left hand side is the same as integrating the right hand side, each term separately. Then we know that integral of 1 over x minus 3 is nothing but ln x minus 3 in absolute value, and the integral of 1 over x plus 1 is ln x plus 1. And then we have a constant, right? So somehow things work out and we have the answer. So what is the trick? Trick was to be able to write the partial fraction in terms of, the rational function as a sort of sum of simpler rational functions. Okay? So the question is, how do we get this one? So this in fact, so the breaking a rational function as a simpler ones is called the method of partial fractions. So that's what we want to describe now. Well, I think the denominators are easy, right? It's just coming from this factorization x minus 3 times x plus 1. But how do I get 3 and 2? Well, in this particular one, I could do the following, right? 5x minus 3 divided by x minus 3 times x plus 1. I could say, okay, I want to write it as a over x minus 3 plus b over x plus 1. right? And then what is left is simply try to find AB. How do we do it? Well, you can simply bring it to the common denominator, x minus 3, x plus 1, right? And then for this, you need to multiply the first one with x plus 1, the second one with x minus 3, so you get ax plus a plus bx minus 3 times b. Now what we have is, so I have the same denominator, which means my numerator must be the same, right? So I write here 5x minus 3 is equal to, I have ax plus bx, so I can group the x term, and then what is left is going to be my constant term, right? A minus 3b. So this gives me two equations, two unknowns. So my coefficient for x is 5, so which means a plus b must be 5, and my constant term here is minus 3, so a minus 3b is minus 3. So this is a simple linear uh, uh, linear equation, right? With two unknowns. So we have two equations, and we know we can do it. We can also, if you like, use the linear algebra methods. So for example, I can multiply out the second one, right? And then if I sum them up, a is cancelled, we get 4b is equal to 8, which gives me b is 2. And then use any of them. For example, I can use the first one. If b is 2, then a plus 2 is equal to 5, gives me a equal to 3, right? So my a is 3, my b is 2. That's exactly what I have, right? So this method that I described using a simple problem is called the method of partial fractions. Okay, so general description of the method is the following. So to be able to decompose f of x over g of x, where f and g are polynomials, as a sum of partial fractions relies on two things. The first one is I need to make sure that f of x, the degree of f of x, is less than the degree of g of x. Okay? What if it's not? Well, if it's not, you need to carry out the long division, right? You just divide f of x by g of x, right? So carry out the long division. Then you will get one term plus f, another f divided by g, where the degree of f will be less than g, right? The second is, for the denominator, we need to know how to factor, right? If you remember in the previous slide, we had x minus 3 times x plus 1. So we need to know how to factorize g of x. Well, in theory, the polynomials can be factored into linear terms, and maybe possibly also quadratic terms. So yeah, this is sort of one trick, that it might happen that you might have a quadratic factors, right, which cannot be factored into the product of linear functions, product of two linear functions. In that case, we call this quadratic factor the irreducible. Yeah, this might happen. This might happen. But as far as we know how to handle these two case, then the remaining is somewhat straightforward, as we describe in the next slide. So the general method is as follows. So let's say that when I factorize g of x, I got x minus r as a factor with some degree, right? It might be x minus r to the power m, where m is the highest possible power for x minus r. Then what I do is, for the partial fractions related to this x minus r, I write a1 x minus r plus a2 x minus r squared, etc. up to am x minus rm. So what is m? M is the highest power that occurred in the factorization of g of x, right? And as we mentioned in the previous slide, we might have irreducible quadratic factor, right? We might have x squared plus px plus q, which cannot be further break down into linear terms. And it might also appear with some degree, right? So with n, where n is the highest degree. If it's 1, then you simply get like bx plus c in the denominator. You see, it's different. So here, whatever you write on the denominator is 1 less degree, right? So if it's quadratic, you need to add this x factor also here, right? So bx plus c. But for the linear, we only have constants on the numerator, right? But for the quadratic term in the denominator, then your numerator should be like b1x plus c1. And again, if it has degree n, then you have to write n sum of n terms, related to this x squared plus px plus q to the n factor, right? So then you can simply write, you go ahead and write f of x over g of x as a sum of all these factors, right? And then do the integration techniques that you learned so far to integrate these terms. Right, so before you integrate, clearly you need to find out this a1, a2, am's, b1, c1, b2, c2, up to bn, cn's, etc. Right? So you need to find all these coefficients. And if you remember, the way I showed in the previous slides was that once you write the general form for the partial fraction decomposition, you bring them all to the common denominator, and so you multiply out the numerator by the related terms, and then you'll get a general form for the numerator, right? We know that the denominators are equal, right? Denominator is equal to g of x. So then if the denominators are equal, then you say that numerators must be equal. So you say f of x is equal to whatever you got after you brought all these terms under the common denominator. And from where you might get, as we did, a system of linear equations, right? A system of linear equations, and the system of linear equations gives us the solution. Let's do some examples. All right, I want to integrate the given function. Luckily, the degree of numerator, which is x squared, is less than degree of denominator, because in the degree of denominator is x cubed, right? If you multiply this first terms, you'll get x cubed. So we are fine with that. Also, we know how to factorize the denominator. I mean, it's already given, right? So now each one, so x minus 1 appears with degree 1, right? It's just to the 1. X plus 1 is also degree 1. x3 plus 3 also degree 1. So which means the general form is x squared plus 4x plus 1 divided by x minus 1, x plus 1, x plus 3. It should be equal to, so x minus 1, it should be equal to like a over x minus 1 plus b over x plus 1 plus c over x plus 3. That's all, right? Because I have linear terms only, my numerators must be just a constant, right? I don't have a term involving x on the top. And also I don't have x minus 1 square term, because here on my denominator I have the highest power for x minus 1 is just 1. Similarly for x1 plus 1 and x plus 3, right? So now what we do is we bring them all to the common denominator, right? So we write it again as x minus 1, x plus 1, x plus 3. A gets multiplied by x plus 1, x plus 3, right? So A gets multiplied by x plus 1, x plus 3. Then B gets multiplied by x minus 1 and x plus 3. So B gets multiplied by x minus 1, x plus 3. And finally, C gets multiplied by x minus 1 and x plus 1. So x minus 1, x plus 1. Now I see that I have the same denominators, which means my numerator should match, right? So then I have x squared plus 4x plus 1 is equal to, now I need to multiply all the denominator and then bring the x squared terms and the x terms and the constant terms in groups. So from the first one, okay, let's be careful. So x plus 1 plus times x plus 3 is x squared plus 4x plus 3, and then I get b times x squared plus 2x minus 3, and c is x squared minus 1. Okay, so what is the x squared term here? We see that x squared term is a plus b plus c, right? So this is my x squared term. Then I get x term, so here I get 4x, so 4 times a, and from second one I get 2 times b, and there on the last I don't have x term, so that's my x term. And the constant term from the first one is I have 3 times a, from second one minus 3 times b, from the last one I get minus c. So this is my x squared plus 4x plus 1. So now what I see is my coefficient of the x squared is 1 here, right? So this is 1, hence a plus b plus c must be 1. So a plus b plus c is equal to 1. And then I see on the left that my coefficient for x is 4. So I see that 4a plus 2b is equal to 4. And finally, my constant term is 1. So I have 3a minus 3b plus, minus c is equal to 1. So I have a system of 3 equations, 3 unknowns. All right. So how do we solve it? Again, I mean, if from your linear algebra course, you can solve it, or you can do it by elimination. So let me do by elimination. So if I look at the first and the second, also the last one, if I sum them up, the c and minus c will cancel. I get 4a, right? I get 4a minus 2b is equal to 2. And I also have 4a plus 2b is equal to 4, right? So from here, I can sum them up. I get 8a is equal to 6. So I get 8a is equal to 3 over 4. Right, now, once you have for a, you can use, for example, the first one, 4a minus 2b equal to 2, to solve for b. So we have what? So 4 times a is 3, so 3 minus 2 b is equal to 2 gives b equal to 1 over 2. And for c, you can use, for example, the first one. I know a, I know b, so I can find c. So c is going to be 1 minus a is 3 over 4 minus b, which is 1 over 2. So I can bring to the common 4. So it's going to be 4 minus 3 minus 2, which is going to be minus 1 over 4. Thus, my integral becomes the integral of these terms, right? So hence my integral, so let's call it int. So for the first one, a times ln x minus 1, right? So a is 3 over 4, so 3 over 4 ln, but in absolute value, x minus 1. And then b is 1 half, so 1 half times integral of 1 over x plus 1 is ln x plus 1. And for c, I have 1 minus 1 over 4, 1 over x plus 3. When you integrate, you get ln x plus 3 plus constant. All right. Okay, luckily I have only one factor, x plus 2 squared, in my denominator. But because this is square term, it means my partial fractions are of the form a over x plus 2 plus b over x plus 2 squared, right? So that's it. Now I need to find a and b. Well, as before, okay, let's 6x plus 7 divided by x plus 2 squared is equal to, here on the right I bring to the common denominator, which is x plus 2 squared, which means I need to multiply a by x plus 2, so it becomes a x plus 2a. For the second one I have b, right? So again, denominator are the same, so the numerator must be the same. What I have is a equal to 6, right? Because that's the coefficient of x, and constant term is 7, so which means 2a plus b must be 7. Replace a by 6, we get 12 plus b is equal to 7, gives b equal to 7 minus 12, which is minus 5. Hence, the integral 6x plus 7 over x plus 2 squared dx is equal to a times ln x plus 2 plus, how do you integrate bx plus 2? Sorry, b over x plus 2 squared. Well, I could write this term as b times x plus 2 to the minus 2, and if you like you can do like u is equal to x plus 2, etc. But applying power rule, this becomes b times, you increase the power by 1, right? So it becomes minus 1. So this is divided, but anyway. And here we get x plus 2 to the minus 1 plus a constant. Okay, now I know that a is 6, so this is 6 ln x plus 2. So b is minus 5, so we'll get plus 5 times 1 over x plus 2 plus constant. Okay, x squared minus 2x minus 3, I know how to factorize, which is x squared minus 2x minus 3 is equal to x minus 3 and x plus 1, right? So you can say, okay, let's jump into the partial fraction decomposition method. Then this term must be equal to a over x minus 3 plus b over x plus 1, and you try to find a and b, but if you do it, you will fail. Why do you fail? Because we were supposed to check the conditions, right? What was the condition? The condition was that the degree of the numerator, which is 3, must be less than degree of the denominator, but it is not, right? It's not. So if it's not, what we do, we go ahead and carry the long division. So first we need to divide it out. So this term is divided by x squared minus 2x minus 3. Alright, so you multiply by 2x, then you get 2x cubed minus 4x squared minus 6x, and then you subtract. You get these terms cancel. You get plus 6x minus x of 5x minus 3. Now 5x, the degree of 5x minus 3 is less than x squared, right? So this 5x minus 3 is my remainder. Hence, 2x cubed minus 4x squared minus x minus 3 divided by x squared minus 2x minus 3 is equal to 2x, right? Here 2x plus 5x minus 3 divided by, now I can write it as x minus 3 x plus 1. I already decomposed this last rational function, and we know that this is 3 over x minus 3 plus 2 over x plus 1. Hence, I can integrate each term on the right separately, which gives me, so the integral of 2x is x squared, then I get 3 times ln x minus 3, then I have 2 times ln x plus 1 plus a constant. Last problem I'll consider is the following. So I have x squared plus 1 term on the denominator times x minus 1 squared. Well, x squared plus 1 is irreducible because you cannot decompose it further, right? You cannot write it as a product of two linear terms. You cannot. So then what we do? So the general shape, right? That's important. The general shape or form. General form of the partial fraction decomposition is what? Well, for x squared plus 1, I need to write it as ax plus b, right? Divided by x squared plus 1. So that's the general shape. That's it. For x minus 1, because it's square, I need to have two terms for the x minus 1 squared. So let's continue the list. AB now it's c x minus 1 and another one for x minus 1 squared. Okay, so this is the general form. Now that you have the general form, it means you solve the half of the problem, right? Because if you miss one of the terms in this representation, you get in trouble. You never able to find A, B, C, and D. Okay, so as before, we go ahead with bringing to the common denominator. So here we get 2x plus 4 divided by x squared plus 1, x minus 1 squared. Yeah, so common denominator is x squared plus 1, x minus 1 squared. So I need to multiply this term by, let me write, but by x minus 1 squared, right? So ax plus b, so this term is multiplied by x minus 1 squared. So the term c is multiplied by x squared plus 1 and x minus 1. Term d is multiplied, I mean the constant, the coefficient is here multiplied by x squared plus 1. All right. So let me only write the numerators, right? Denominator are the same. So here I get minus 2x plus 4 on the right. What do I have? Well, okay, so x minus 1 square is x squared minus 2x plus 1. So let's multiply this by ax plus b. So I get ax cubed minus 2ax squared plus ax, and then multiply by b. I get bx squared minus 2bx plus b plus, now x squared plus 1 times x minus 1, so you get x cubed, so we get c x cubed. Then I get minus x squared, so minus cx squared. Then I get x plus cx, and 1 minus 1 is minus c. And then from the last term I get dx squared plus d. Now, on the left, I don't have x cubed, which means x cubed term must be 0. So I get ax cubed cx cubed, which means a plus c must be 0. Also, on the left, I do not have x squared, which means x squared terms should be 0. So where are they? So here's x squared term, here's x squared term, here is x squared term, and there is the x squared term. So what do I get from there? I get minus 2a plus b minus c plus d. So that's also equal to 0, right? And then I have minus 2x. So x term must be minus 2. Here's my x, here's my x, here's my x. So I get a minus 2b plus c is equal to negative 2. And finally, the constant term is 4. So my constant term is here b, c, minus and d. So b minus c plus d must be 4. So I have 4 unknowns, a, b, c, d. I have 4 equations, right? All right. Well, how do we solve it? Again, I mean, we can do by elimination or substitution. So here, b minus c plus d, we already have it, right? It's 4. So this gives us that minus 2a plus 4 is equal to 0, which gives me a is equal to 2. But if a is 2, then from the first one, I get c is equal to minus a, which is minus 2. Okay, so now I have a, so I can use the third one. A is 2, we don't know b yet, c is minus 2, so this is equal to minus 2, which gives me b is equal to 1, right? So now that I have b and c, I can use the last one. So b is 1, c is minus 2, so it's going to be plus 2, plus d is equal to 4, gives me d equal to 1. So now that I have my coefficients a, b, c, d, I can go ahead and integrate, right? Well, so what do we have? I have ax plus b, so it's 2x. So this is 2x plus 1 divided by x squared plus 1 plus c is minus 2, so this is minus 2 divided by x minus 1. D is 1, so 1 x minus 1 squared. What do we do for the first one? Well, I can split 2x plus 1 as 2x plus the 1. So this becomes the integral of 2x divided by x squared plus 1 plus integral 1 over x squared plus 1 minus integral of 1 over x minus 1 plus integral x minus 1 to minus 2. The first one is by u substitution, where you let u equal to x squared plus 1, then du is 2x dx, so everything works perfectly fine. We see that this is ln x squared plus 1. Then the integral of 1 over x squared plus 1, this is arc tangent of x. Then we get ln x minus 1. So here I put absolute value, but in the first one I didn't put absolute value because x squared plus 1 is already positive. And then finally the x minus 1 to the minus 2 is it's x minus 1 to the minus 1 divided by minus 1 plus a constant. I'll stop here.